Welcome back. In this video, I'm doing daily, not daily, but Leetcode problem 1140 Stone Game 2. So actually it was a daily problem, but a few days ago, and it's a medium, so let's check it out. Alice and Bob continued their games with piles of stones. There are a number of piles arranged in a row, and each pile has a positive integer number of stones. Piles of 5. The objective of the game is to end with the most stones. Alice and Bob take turns with Alice starting first. Initially, m is equal to 1. On each player's turn, that player can take all the stones in the first x remaining piles where 1 is less than x is less than or less than equal x less than equal 2 times n. Then we set m. Okay, so we increase m if we use more than. Okay, the game continues until all the stones have been taken. Assuming Alice and Bomb play optimal, return the maximum number of stones Alice can get. Okay, let's try to code this up. How are we gonna start? Let's first take n is equal to one of files. Know how many files we have. Mm, mm, mm. Okay, let's try this this approach. Let's call it stones left. It's actually stones right. Let's call it stones. So stones will be equal to so number of stones we have from this index till the end. So this times n stones of minus I will be equal to piles of minus 1 and for in range. So we'll start from n minus 2 minus 1 to minus 1. From n minus 2 to minus 1, minus 1 step. We update our stones of I is equal to stones of I is so piles of I plus stones of I plus. Okay, now we have that. So now we have so from this position, how many stones there is to the right. So let's try this. Let's call it helper, which will take our index and current m. And let's check the base case. So base case if index is greater or equal n, let's return 0. If not, we need to see what's the max stones. So max stones is equal to 0. And what do? So we need to, we'll try each possible number of, let's say, files we can take. So X, we need to check. So for, I'll call it X in range. So 1 is minimum and maximum is 2 times M plus 1 because this number is not included in range. And what do? So we need to check if so if index plus x is so greater than 10, because when we are on the last index, if we take that one, then we will be equal to n, because index is n minus 1 and x is at least 1, meaning x is taking that one, so that's okay. So that's why we need to be greater than n, not greater equal. Okay, here we break out of the loop and max stones is equal to max of max stones. And so are we going to know what do we need to take max of? We need to make recursive call now because next person needs to play. Just find this. Okay. And for this much space. Okay. So max of what? We need to check stones of current index, meaning this is the maximum we can take from this position on. But we need to subtract from it what will other person take. So helper helper of, so index is index plus x, because x will be 1 in your case. This also point, this will point, this will be, this new index will be the next pile we had. And we need to take max out of, so x we took and current m we had. Okay, this should be correct. And we just return max stones. Max stones. Okay. Yeah, we'll need to introduce like cache, but let's see if this will work. And we just return, so helper of index is 0 and m is 1. Let's try to run this. I. is if long index. Okay, so it works. We'll probably get time exceeded because we will have repeated some parts, because when we calculate the so when we find ourselves at index, let's say 0, let's say index for this situation uh, 9, and we solve this problem, there is multiple ways we could have ended up at 9. So it could be from 2. So first player Alice takes only 2, Bob takes only 7, and so on, and then Alice takes 9, or Bob, since we're gonna pass all the examples, or Alice takes both 2 and 7 because she can take it. X is between 1 and 2n. And then Bob takes 9. So in multiple situations, when we start, like, let's try to go through this example. So we'll take the number of the length of this, so it's 5. We'll initialize stones to track how many stones we have to the right from this pile. So stones, this pile plus all to the right. So what's the stones left if this was played? And the current position is at index. We'll update our stones to track it. So stones will be of 0, 1, 2, so 4 will be 4, 8, 17, 24, and 26. Okay, and we call helper. So we are at 0, at index 0, and we call it for M1. And we check if current index is so out of, if there is no piles left, so it's not, it's okay. We say max stones is 0, and we go from X in range of 1, 2, so 2, 3, but this is so 1 and 2. And we check if it's out of range, and if it's not, we see, so our max stones is 0. This will be done only for 1 and 2. So we'll one time we'll call this helper for so one time we'll call this helper for index 1, another time for index 2, and we'll have different m's in that calls. And so the one that will, the call for index 1, so that's starting from here, will get us okay, we'll have to like go to the end. Let's see, maybe. So for this call, we can still go 1 or 2. So only this or this. If you go 1, 1, yeah. Like I can't, the trees, like there's so many possible like ways to go, and that's why we'll repeat many times some of them, and that's why we need to take so we need to have some kind of cache. So cache, and now have cache of so cache will be equal, well, not cache, but cache will be equal to, so 0 times times n times So greatest m we can have, I'll call it n minus n minus 1. So if it's n, I have m that is n. Can't do it. Yeah, let's do it like this. Or actually, let's do it like this. So this times n. So this more, so this times this will reach n. So we'll have, yeah, should be okay. And here we're gonna ask if so cache of index and m not equal to 0, return it. And we are here going to store. So actually is equal to max. So this should make it a lot faster. Well, not here, here. Okay, let's try to submit it. Index of m. It seems it has to be m plus here. Right now. And yeah. Okay, so looks good. I was looking for this part, I'm not sure. Let's try it. So do it again. I'm not sure how this fails. Index is out of range. If cache index m, I thought it will be for this, but I'm not sure how. Index. Let's try it. So if it's 1, so n is equal to 1, stones is also just 1. Stones of loss is pounds of loss. Okay, so 1 cache is so only 0 and 49 0 1, so it's only 0, so it will be only this one. For I in range n minus 2, minus 1 minus 2, but n minus 2 to the minus 1, so this won't do anything. And we're gonna call helper 0 1, helper 0 and 1. Okay, I see the problem because m will be 1, but yeah, m will be 1 here, and index is 0, and we only have element at cache of 0 0. So okay, makes sense. You should always be careful with this part because not okay. Because it's like edge cases in a sense. Check it out now. Okay, it works. So for the time and space complexities, because of cache, So what's the first thing? So we said because of the cache, that's off, and so n times n, and for time complexity, so we have n indexes, and each n index can be we can like have it as a starting position in our helper, and also for each of that we will have we'll try all m's possible. So m's in the worst case are n, as we saw in that one example. Uh, and we do this loop, so we'll call this n times n squared times, and we do this loop to the 2 times m until we like break with n, so that would be n cubed. N cubed. Okay, I hope it makes sense. This was a bit harder one, but thank you for following, and I hope like you understood everything I said. These DP problems can tend to have like problematic solutions, let's say. Uh, okay, I'm wrapping it up. Thank you for following, and see you in the next one.